System Engineering Unit 3 is a frequency response analysis. So in frequency response analysis, many of the plots, Bode plot, polar plot are available. First we are seeing the Bode plot. Okay, so the Bode plot means a straight line approximation of the Bode plot may be drawn quickly from knowing the poles and zeros of the system. So the response of Bode plot, it approach a minimum near the zeros and maximum near the poles. So the overall effect of constant zeros and poles term means, see the tabulation, the term means constant, zero and pole. The magnitude break in zero is upward and pole is the downward direction. So asymptotic magnitude slope means plus or minus 20 dp per decade. Zero means positive 20 dp per decade and pole means minus 20 dp per decade, and the asymptotic phase shift values is 0 means plus 90 degree and pole means minus 19 degree. First, so Bode plot. So what is the definition of Bode plot? Means a Bode plot is a semilog plot. It is using the semilog graph for calculating the transfer function of the magnitude and phase angle as a function of the frequency. The magnitude and phase value will be noted or find out for the function of the frequency. So the gain magnitude in many times expressed in terms of the decibel dB. So dB is equal to 20 log 10 of A. A is nothing but the amplitude or gain. So a decade is defined as 10 to 1 of the frequency range. An octave is any 2 to 1 the frequency range. 20 dp per decade is equal to the 66 dp per octave. So the Bode plot transfer function is expressed in standard form of h of j omega is equal to k of j omega plus or minus n into 1 plus j omega and etc. So here we are using the 4 different factors. First one is the constant gain term k, then poles are zeros at the origin j omega plus or minus n, poles are zeros of the form 1 plus j omega tau, quadratic poles are zeros of the form. So if the Bode plot means, we can combine the term constant gain k and then the n pole s are zeros at the origin such that the magnitude crosses the 0 dB. Next we are finding out the poles and the zeros. So see, this is the Bode plot summary. First one the factor, then one the magnitude behavior and then the phase behavior. So this one is the graphical representation of the single pole and the zeros in the Bode plot. So next one is the Bode plot refinements. So further refinement of the magnitude characteristics of the first order pole and zero is possible means, the magnitude at a half break frequency is denoted as plus or minus 1 dB. Magnitude at break frequency is denoted as plus or minus 3 dB. Magnitude at twice break frequency is denoted as the plus or minus 7 dB. Then the second order poles and zeros require the damping ratio by taken into twice the value of the decibels. So next one, the Bode plot, how to convert the Bode plot to the transfer function. So first the Bode plot and extract the transfer function means, it is relatively there will be error associated with our extracting information from the graph. So first we are determining the constant gain factor k and then move from lowest to highest frequency, noting the appearance and order of the poles and zeros. So here examples. Determine the system transfer function given the Bode and the magnitude below means, we are find out in the values of the Bode and magnitude plot values.